You've seen them on the news, right? These sudden, just catastrophic downpours. We're talking about cloudbursts. They're some of nature's most intense, most destructive weather events. And today, we're going to pull back the curtain and really look at the anatomy of how they happen. I mean, how is that even possible? How can a single cloud unleash a month's worth of rain in just 1 hour? It sounds like something out of a movie, but it's real. And we're going to break down exactly how it works.
Okay, so let's start with the immediate aftermath. Because a cloudburst, it isn't just about the weather. It's really about the ground. Its story begins with the sudden, violent impact it has on everything below.
I mean, just try to picture it. A tiny stream you could hop across becomes a raging, destructive torrent in literally minutes. This is way beyond just heavy rain. We're talking about flash floods, landslides, entire villages getting washed away. The consequences are terrifying because there's just no time to react. So what is a cloudburst, really? What's the official word from meteorologists? I mean, the name itself sounds pretty dramatic. And trust me, it's for a very good reason. Let's dig into the definition. It all boils down to this one number, 100 millimeters per hour. That's the magic number. To be officially called a cloudburst, you need at least that much rain falling over a pretty small, very localized area. Think about 20 or 30 square kilometers. Now, to put that 100 millimeters figure into perspective, that's the amount of rain a place might normally get over several weeks. A cloudburst just dumps it all, the whole lot, in 60 minutes. It's just an absolutely incredible, concentrated force of water. Okay, so how on earth does the atmosphere even create something this violent? Well, it's not random. There's actually a recipe for it, a very specific 5-step process that turns a normal cloud into, well, a weapon. And you'll see it almost always starts in the mountains. It really is like a trap. So, step 1, warm, moist air rolls in. Step 2, it hits a mountain and has nowhere to go but up. That's called orographic lifting. As it rises, it cools and forms these huge, towering storm clouds. But here's the crucial part. Step 4, incredibly strong winds or updrafts inside that cloud act like an invisible hand, just holding all that water up, preventing it from falling. It's like a dam in the sky. And then, step 5, the burst. The updraft weakens or the water just gets too heavy and that dam breaks. The entire payload gets dumped all at once. All right, so now that we know how it happens, let's talk about why it's so incredibly dangerous. This science directly explains that cascade of disaster we see on the ground. It's a horrifying chain reaction. Think about it. The ground just cannot absorb that much water that fast. So you get instant flash floods, rivers become raging torrents, and at the exact same time, all that water soaks into the soil on hillsides, making it heavy and unstable. It loses its grip, and that's when you get the devastating landslides and mud flows that can literally destroy roads, bridges, and isolate whole communities. And there's a human factor here that can make this so much worse. Deforestation. This quote really hits the nail on the head. Trees and their roots are like a natural net holding the soil in place. You chop down those trees and that net is gone. So when a cloudburst hits, there's nothing to stop the topsoil from just washing away, which dramatically increases the risk of a truly catastrophic landslide. What's maybe the most terrifying thing about all of this? They're almost impossible to predict. Because they happen so fast and over such a small area, they can completely fly under the radar of our standard weather forecasting models. That means people in the path often get little to no warning at all. So this isn't just about understanding a single storm. We need to zoom out because there's a bigger picture here, and that brings us to our warmer, more unpredictable future. So if traditional forecasting doesn't work, what do meteorologists do? They use something called nowcasting. Forget predicting the weather for next week. This is all about the next 0 to 6 hours. It's about looking at radar and satellite data in real time to spot these developing threats. It's our best shot, but for something that develops as quickly as a cloudburst, it is an incredible challenge. And scientists are seeing a couple of key factors that might be making these heavy rain events more likely. First, on a global scale, there's warming. It's pretty simple physics. Warmer air can hold more moisture. More moisture means more fuel for bigger storms. Then, on a more local level, you have urbanization. All that concrete and asphalt in our cities absorbs and holds heat, and pollution particles in the air can actually act as seeds for raindrops to form around, potentially making intense downpours more common. Which really leaves us with a huge question, doesn't it? As our atmosphere continues to warm, Are we actually prepared for nature's most intense downpours? We understand the science behind them, we see the trends, but adapting to a future where these kinds of sudden, violent events might be more common, well, that's the real challenge ahead of us.